so let's look at our schedule. We started lesson 8 on Tuesday, 8S. So today we're going to finish lesson 8 and then cover lesson 9. Okay. Then we've got one more class on Tuesday. Yeah, one more class Tuesday the 29th before our next quest. So quest 2 is going to be on Thursday, October 1st, a week from today. I will tell you a little bit more about it on Tuesday, but for now I'll tell you it covers lessons 6 through 9. Okay, so what we talk about today from lesson 6 all the way through today is what's going to be on quest 2. Okay? And just as a reminder, the resources you have for quests, you have the practice problems packet. Right, the practice problems packet with solutions, video solutions in Moodle. Okay, so you have lots of practice problems you can do, the video solutions to them in Moodle. You have your even more practice. From every lesson has an even more practice section. So if any of them that you haven't done yet, you can go back and do those. There aren't videos, but you do have all the answers to those. And then also, you can create one page of notes. Okay, it's front and back. You can bring it with you to the quest. You can put whatever you want on it, examples, formulas, anything you want. The only stipulation is that it has to be written or typed by you, right? Not a photocopy of somebody else's sheet, not a photocopy of the book or notes from class. You have to actually write it or type it with your own 2 hands. All right, so those are resources for preparation for the next quest. And let's have a little reminder of what we did at the end of last class. We were talking about lines of best fit. This was lesson 8, where you get some real world data. You make a scatter plot out of the data points, and you draw a line of best fit. And we were just eyeballing the line of best fit, so everyone's line is slightly different, so people were getting slightly different answers for their equations, and that's okay. So you can pick 2 points that are right on your line, right? Not 2 of your data points, but 2 points that are on the line of best fit that you drew. And you can come up with the equation of a line the same way we did if I gave you 2 points. And then another word for the line of best fit is a regression line. And they're really handy for making predictions, right? That's what they're good for, is that if you have some time or some year that you don't have a data point for, you can use your line to predict what the data might have been in that year. So if your unknown data point is between the beginning and ending of the data that you were given, we call it interpolation. Outside of the given data, we call it extrapolation. All right, and so we started these activities last class, and I think most people had gotten through like maybe number 1-ish. So I'm going to have you pick up wherever you left off in these activities. Okay, I'm going to direct your attention to the quick check. Everybody freeze for a minute. Turn to page 66. Page 66, the quick check. I'm going to have you work on this for a minute or 2 before we start the next lesson. And I'm going to give you a little reminder because we haven't reviewed this today, right? You want to find the equation of a line that goes through the point 2, -1 and is perpendicular to a given line. It's perpendicular to y equals 7/3 x plus 14. So what's the slope of this line? Yes, the slope of this line is 7/3. Okay, what's the slope of a line perpendicular to that? -3/7. Okay, so the line we're looking for, our line, goes through the point 2, -1, and has a slope of -3/7. So see if you can take these two pieces of information and find the equation of a line. Line that goes through the point 2, -1 and has a slope of -3/7. Do this quick check together. So we're looking for the equation of a line. So I start by writing down the most general equation of a line I know. There are exceptions. When does a line not have an equation that looks like this? Oh, yes, you could use point slope form, but you can always turn point slope form into slope intercept form. There's a special kind of line that cannot be written like this. Vertical line. Yeah, good. So any non-vertical line, you're going to use y equals mx plus b. All right, I have the slope, which is the m. So I'm going to replace the m with a -3/7. Okay. And then they did not tell me the y-intercept, but they did give me a point, right? So I can plug in my point for x and for y and solve for b. So my point is 2, -1. So the -1 is the y-coordinate. I put that in for y. My 2 is my x-coordinate. I put that in for x. Okay, so now we have to be dealing with fractions a little bit. So -3/7 times 2 is the same thing as -3/7 times 2 over 1. Multiply fractions, you multiply the tops and you multiply the bottoms. So my -1 on the left stays the same. This becomes -6/7 plus b. Then to get b by itself, I add 6/7 to both sides. So we get b is, well, -1 is like -7/7 plus 6/7 would be -1/7. So my final equation is go back up to right here where I was almost done. I had y equals -3/7 x plus b, and now I know what b is. So I replace it. Y equals -3/7 x minus 1/7. Okay. Lesson 9, we're going to do some more in-context linear problems. So we won't be drawing lines of best fit, but this is going to be really similar to what you were just working on. So this should be some even more reinforcement of finding equations of lines with in-context problems. All right, so according to a report in USA Today, sales for personal breathalyzers have spiked in recent years. And the CEO of Wintergreen Research reported that the 2009 personal breathalyzer market was $215 million. So I'm going to circle this. 2009, we have a value, right? A year and a market value. All right, and then we have another set of values for a different year, right? In 2005, it was only 28 million, right? So it's a really big jump from 28 million to 215 million over 4 years. So I'm going to do that one in a different color, 28 million, 2005. Okay, so we're going to assume that sales are growing at a constant rate. Sales grow by the same amount each year. And we're going to use these figures to predict the value of the personal breathalyzer market right now in 2015. All right, so I'm going to define two variables for this situation. Which one is independent? Which one is dependent? Years are independent, yeah. So years are going to be the independent variable. I don't really want to use numbers in the thousands, like 2009, 2015, right, 2005. So let's measure in years since 2000. Just makes it easier to count, and I can use smaller numbers. All right, so my independent variable is going to be years since 2000. All right, and then my dependent variable is the other piece of information that they gave me, which is the value of the personal breathalyzer market, right? Personal breathalyzer market. And let's measure this in millions, right? So that I don't have to write 6 zeros every time I want to tell you how large the market is. In millions of dollars. Okay, so the question gave us two ordered pairs that fit our two variables. So what's my first one? The one I circled in pink. How would I write that as an ordered pair? Super close. 9, because we decided to measure it. Well, I decided to measure in years since 2000. So it's just going to be 9, comma 215. And I don't have to write million because I just said, just remember that this is all in millions. Right? And then my other point is the one I circled in green, 5, comma 28. That represents 2005. The market was 28 million. Okay, so I was able to extract 2 data points, 2 points from the story, from the article, whatever. And then I'm going to try to use those 2 points to write the equation of the line. Okay. Hint, always start by finding slope. Right? So my slope is my change in y over my change in x. So 215 minus 28 over 9 minus 5. 187 over 4. And let's get a number for that. 46.75. Is that exact? Okay, then I don't need that squiggly equal sign. What are the units on that 46.75? What does that 46.75 mean? Yeah, that is how much the breathalyzer market grows by each year. So when I did 215 minus 28, remember that was millions of dollars. Right? And the 9 minus 5, that was years. So my final unit is millions of dollars per year. Once you have the units written down, it's easier to like try to identify what that's measuring. The growth of the personal breathalyzer market. All right, so once I have the slope, I write down y equals mx plus b. Replace the m with 46.75. And then I have to figure out b. I need a point. I have 2 points. I'm going to use the smaller numbers because it's just a little more friendly. So we replace the x with a 5. I don't know b. That's the whole idea. I'm trying to figure out b, so I leave that as my unknown. And I replace my y with the y coordinate of 28. Okay, so 46.75 times 5 is 233.75 plus b equals 28. So I'm going to subtract 233.75 from both sides. And I get negative 205.75. Should I just circle that number and I'm done? No, right? That's the y-intercept. It's not the equation of the line. So the equation of the line, right? I was halfway done like 6 steps ago, right? I had the slope. So I go back and I rewrite it. Y equals 46.75x. And then plus b, but now I know b is negative 205.75. So there's the equation of my line. So to interpret the meaning of the slope, I already kind of made you do that when I wrote the units next to the slope, millions of dollars per year. So the slope represents the market, personal breathalyzer market, is growing by $46.75 million each year. And if I want to predict the value of personal breathalyzers that will be sold in 2015, that's what my equation is for. Okay. I only have the value of the market for 2 different years. I know the value in 2009 and 2005. So the article didn't tell me anything about the current market value. But now that I have an equation of a line, I can find out the current market value or predict it. So 2015, is that an X or a Y? X. And should I plug in 2015? Just 15. So that corresponds to X equals 15. So I'm going to replace my X in the equation with a 15. Y is 46.75 times 15 minus 205.75. And so I get Y equals 46.75 times 15 minus 205.75, 495.5. 495.5. And what does that number mean? Millions of dollars in 2015. Yeah. So if I want to write a complete sentence, I would say the personal breathalyzer market, which I abbreviated to PB because I got tired of writing it. The personal breathalyzer market is worth $495.5 million in 2015. Yeah. Okay, so you can see this is really similar to what we just did, except instead of having lots and lots of points on your line to choose from, you have to very carefully read whatever it is I give you to read, some small excerpt from an article or something, and extract 2 data points. Once you've pulled out 2 data points, the rest of it is exactly the same as what we've been doing for the past couple of classes. All right. So that's it for the demo part. I'm going to have you work on some activities.